go for the final statement. Now, what does it mean? Suppose I have a system of n particles, right? If different forces are acting on different particles, now look at this, it's a rigid body or the system of n particles. If different forces are acting, external forces, I'm not talking about the internal forces. I'm only talking, we are just neglecting the internal forces. When different forces are acting, F1 is acting on particle of mass M1, F2 is acting on particle of mass M2. So when different forces are acting on different particles, then look at the final statement. The total external force, say if this is 1 Newton, so I'll give you the 2 and this is 3. Say the total external forces happens to be 10 Newton. Now this total force is going to, it looks like the total force is acting on the center of mass. That is what this expression denotes. What does this expression denotes? Ma is equal to F1 plus F2, etc. up till Fn, or this expression. Now, what does the expression interprets? It interprets if there might be a number of forces acting on individually on each particle of the system, but it appears that the total force acts only on the center of mass, so that the center of mass gets accelerated by A. Is this clear? 11B? 11B? 11th standard?
Ma'am, that
Ma'am, that
A would
A
be
would
the
be
acceleration of the
the
whole body.
acceleration of the whole body.
Capital A is the acceleration of the center of mass. Boys, there might be an echo you will be hearing. The reason is that the next I have put inserted a video clipping over here. Might be that's the reason. There might be an echo. Just hold that words. A is the acceleration of the center of mass. Capital V is the velocity of the center of mass. Should I repeat 11B? Because this is a slightly a difficult concept as a whole in physics in grade 11. Should I repeat? What does this statement, if I can highlight, what does this expression denotes? MA is equal to F external. Boys, understand? Capital M is the total mass of the system, which appears to be concentrated at the point what we call it a center of mass. A is the acceleration of the center of mass. Right? So you have a system of n particles. Now each particle have different masses. Say when a force F1 is acting on the first particle, F2 is acting on the second particle, Fn is acting on the nth particle. So, but the total force acting on the system is F external. Might be individual forces acting on individual particles might be different, but what is happening is that it looks like there might be different forces acting on the system, but the total external force acts on the center of mass, so that the center of mass is accelerated by an acceleration A. The, it is always that. There might be a number of forces acting on the system, but the total force appears to act on the center of mass, so that the center of mass gets accelerated by A. That is the final statement. Especially this chapter, since a new concept, it's advisable every day you go home, just keep doing. You will understand it better only when you redo whatever is being done in the class. Boss, have you completed? Shall I move for the next concept? 11B.
Ma'am, we have to write
Ma'am, we
last
have to write last bit.
Okay, you have to write. Fine. You need time, you just inform me, I'll wait for you.
Man, do we have to write all the
And
boxes?
we have to write all the boxes.
Everything. So all this I have taken it from your textbook, so you need to
Ma'am,
write
the
that.
last
Ma'am, the
thing
last
we wrote is
thing
M
we wrote is
R is
M
equal
R
to
is equal to.
Which one was? All what is
Ma'am, could
being.
you once again
Ma'am, could you
go to
once
the previous
again
slide?
go to the previous slide?
Okay. Yes. Kavin? Sorry, Kavin is another class. Kavin?
Yes, ma'am. Yes, ma'am.
Samuel? Samuel? Samuel, I saw your message once I had left. Samuel is here?
Ma'am, I replied in the chat.
Okay, fine. His system is not working, boys. Just ask him whether his system is not working. Because I have to once.
Okay, ma'am. Okay, ma'am.
Shall we start with a vector product, boys? Shall I start with this?
Ma'am, can you show the slide that we explained right now? On the next one.
Second slide.
Next one.
This one?
Yes, ma'am, this one. Yes, ma'am, this one.
You just put it in the chat box, boys.
Okay, thank you, ma'am. Okay, thank you, ma'am.
Kritya? Vector product, we call this as the cross product of two vectors. We'll see what is, suppose if I have two vectors, A vector and B vector. What will be the cross product of this? It is A vector modulus. Modulus means it is the magnitude of vector A and vector B and sine theta. Theta is the angle between both vectors. We'll see the literal meaning. This is the mathematical expression. Boys, this concept is very important even when you go for grade 12. In grade 12, you will be using the cross product. Okay. Now look at this. Suppose you have learnt in grade 10, when a current carrying conductor is placed in a magnetic field, it will experience a force. Yes or no, boys? A current carrying conductor, when you suspend it in a magnetic field, it will experience a force and begins to move. It undergoes a translatory motion. Same way, suppose if I have a magnetic field, right? Magnetic field exists between two magnetic poles. Say I'm just taking a U-shaped magnet. So the direction of your magnetic field is always from north to south. Suppose a charged particle, say a proton, right? A charged particle is going to enter your magnetic field. Say it can enter straight. So the angle between them is 90 degrees. Because all these are happening in a plane. Do you understand what do you mean by a plane? Is that clear, boys? Your whiteboard becomes a plane which has x-axis as well as a y-axis. Imagine you have a magnetic field, right? And a proton, a charged particle, is moving in a magnetic field with a velocity v. Now, this charged particle, when it enters a magnetic field, it will experience a force and then it begins to move. Now, how to find the direction of the force? And that is given by right hand thumb rule. Is that clear, boys? Now, look at this diagram. Look at this diagram. Now, this will be the direction of B vector. B vector is your magnetic field vector. B vector represents your magnetic field. V vector, I can highlight. B vector is the magnetic field vector, the direction of the magnetic field. V vector is the direction of the motion of the charged particle. Are you clear? 11B, are you clear? B vector. B vector, sorry. B vector is the direction of your magnetic field. V vector is the direction of the motion of a charged particle, which means a charged particle is entering into a magnetic field. Was a charged particle entering into a magnetic field and electric field. This concept is very, very, very important in all your particle accelerators, as well as have you long back we used to have what do you call this as the cathode ray tube of your television. Now we have LCD monitors. Long back we used to have that picture tube. Right? The picture tube of your television sets, it works on this principle. When a charged particle enters a magnetic and an electric field, this is how on your screen, you can see the picture being scanned pixel by pixel. This is what is happening. A charged particle, you have a cathode ray tube. At the moment you switch on, the cathode ray tube gets illuminated, stream of electrons will flow. These electrons are made to pass through both magnetic and electric field, and finally these charged particles will be scanned all over the screen of your television sets. This is the basic principle of working of your television sets. A part of it, right? Now look at this. A charged particle is entering along the direction V vector in a magnetic field B vector. Now it will experience a force. Whenever a charged particle enters a magnetic field, it will experience a force. Now what will be the direction of the force? Now how to find the direction of the force? Provided B vector and V vector are lying along a plane. Can you imagine B and V vector are lying along the plane? Say if I take B vector is lying along your x-axis, B vector is lying along your y-axis. Are you clear, boys? Which means your charged particle is moving in an xy plane. Now how to find the direction of the force experienced? Look at the statement. Place the tails of V vector and B vector together. So the tail of B vector and the tail of V vector, we are placing them together, say at this point. Then next one, point the fingers in the direction of V, of your right hand. Of the right hand, the fingers, all the fingers, all the fingers of your right hand should be kept along the direction of V. I think so. Can you do that? I'll show a video, but at least right now you can do. All your 4 fingers of your right hand, right? Keep them along the direction of V vector. And then next step, curl all your fingers of your right hand towards V. So first stretch, boys. First stretch all the fingers of your right hand along the direction of V vector, and then move all your fingers or curl all your fingers in the direction of B vector. Then in which direction will your thumb point? 11B, in which direction will your thumb point? Adam? Adam, in which direction will your thumb point? Is it pointing upward or will it point downwards? If people are not getting it, I'll just go for a video clipping. Just listen.
So I wanted to make this to talk a little bit.
Boss, can you hear? Boss, can you hear? 11B?
Yes, ma'am. Yes, ma'am.
So I wanted to make this to talk a little bit about the right-hand rule for the cross product. It's a little difficult to explain over text, so I figure it's best to actually show you how to do it. So that being said, I am kind of limited in terms of what I can do with this camera because I have to hold it in my left hand. I don't have an actual stand for it, so I'm limited to one hand, but I do want to show you the idea behind it. So if we have A cross B like that, then the idea here is that you're going to put your hand straight out, flat like this. You've got your plane here. This piece of paper is my plane. And you're going to put your hand, I'm going to just spin it, just once again limited. You're going to put your hand across A here. And if you can curl your fingers to point B, right? Because I can't curl my fingers backwards like that. That doesn't work. So if I can keep my hands steady and curl my fingers towards facing B, then I know my thumb is the direction that my cross product is going to go in. So in a similar fashion, if I say B cross A, I start my hand at B, and I can't curl my hands back, so I know it's not this direction, but, and once again limited here, if I put my thumb down here like that, I can curl my hands in this direction towards A. So I know that my cross product is going down into the page. So that's how you do it. It's also commonly done where you hold your finger kind of like this, like you're shooting an elastic band gun type of thing. And if you can point, or keeping your index finger steady, if you can point your middle finger towards it, which I can't really do here once again, but if you do it upside down, you can do it, right? So I prefer though. So I wanted to make this to talk a little bit about the right-hand rule for the cross product. It's a little difficult to explain over text, so I figure it's best to actually show you how to do it. So that being said, I am kind of limited in terms of what I can do with this camera because I have to hold it in my left hand. I don't have an actual stand for it, so I'm limited to one hand, but I do want to show you the idea behind it. So if we have A cross B like that, then the idea here is that you're going to put your hand straight out, flat like this. You've got your plane here. This piece of paper is my plane. And you're going to put your hand, I'm going to just spin it, just once again limited. You're going to put your hand across A here. And if you can curl your fingers to point B, right? Because I can't curl my fingers backwards like that. That doesn't work. So if I can keep my hands steady and curl my fingers towards facing B, then I know my thumb is the direction that my cross product is going to go in. So in a similar fashion, if I say B cross A, I start my hand at B, and I can't curl my hands back, so I know it's not this direction, but, and once again limited here, if I put my thumb down here like that, I can curl my hands in this direction towards A. So I know that my cross product is going down into the page.
11B, do you understand how to find the direction of the two vectors, cross product of two vectors with the right thumb rule?
Ma'am, A cross B is not the same as B cross A.
A cross B will not be same, direction will change. Magnitude doesn't change, direction will change, boys.
Okay, ma'am.
So, okay, did you get that? And we'll do a numerical based on the thing. Just copy down this, boys. Definition of a vector product. Definition of a vector product. Only this much is enough for you right now. A vector product of two vectors A and B is vector C such that I can write vector A cross vector B will be equal to C vector. In terms of magnetism, I can say V vector cross B vector will be equal to F vector. So I can write that C vector becomes equal to modulus. Modulus means only the magnitude of A vector, magnitude of B vector, sine of the angle between A vector and B vector. So you have seen in your video clipping, this was A vector and this was B vector. The angle between them was theta degrees. So C vector will be A vector. And very important concept is this. C vector is perpendicular to both A and B. If A vector and B vector are lying along XY plane, then C will naturally lie along Z axis. Are you clear, boys? Kritya? Kritya is here. Kritya, his microphone is not working because he was asking for cross product as well as a dot product. Boys, is that fine for others? 11B, you're quiet.
Yes, ma'am. Understood.
Yes, ma'am.
Okay, we'll do a numerical. Boys, have you started with matrices? Have you started mathematics matrices?
No, ma'am.
Have you started?
No,
You
ma'am.
have not started. I don't know how to.
Ma'am,
Okay,
we
anyway.
were writing it,
Yes, boys, you were writing that. Okay,
the last slide.
fine, fine. You haven't started with matrices. Determinants. Determinants.
No, ma'am.
No, ma'am.
Nothing. Okay. Now, why we are doing? Sorry, we are just checking up your cross product because I think most of you are appearing for your SAT exams, all those things. So that is why we are not deleting all those things. I'm just doing it not only from board's point of view, for your competitive examination also. Shall I go for the next one, boys? Shall I go for the next one?
Yes, ma'am.
Okay. So whether you understand this or not. Okay, fine, boys. Now look at this. I have two vectors, A vector and B vector. Here, say I can have this as 5i cap plus 6j cap minus 7k cap. So I have a vector A and vector B. How to find the cross product A vector cross B vector? Now I have to how to find that. Right? Now this is called finding the determinant. Maybe I don't know how to put determinant because you are not introduced to matrices right now. Okay, fine, boys. Can you see this one? I, J, and K. Whatever I have encircled. So I'll go for an empty slide. That would be better. Listen, suppose if I have a vector A is given as, I just go for 2i vector minus 3j vector plus 4k vector. Then B vector, I'll just have it as minus 2i vector plus 1j vector minus 2k vector. Okay, fine. Now my aim is to find A cross B. So how to find vector A cross B? This is what we call it as the determinant form. What I'll do is I'll put this as I cap, J cap, K cap. Then I'll put the coefficient of I cap of A, that is 2. Can you identify? So this becomes 3 minus 3. Next it becomes 4. Then I'll go for the second vector. So the coefficient of I cap is minus 3. And for J it is plus 1. For K it is minus 2. I have arranged in the determinant form. Is that clear? Right now, this much is enough for you to understand the mathematical concept. But is that clear what I have done? Is that clear, boys? I want to find A cross, vector A cross B. Right? So I'm using this determinant form where I'm using I, J, and K. So what is the coefficient of I? 2. What is the coefficient of J? Minus 3 for the first vector. K, 4. Is this clear? I have to call Shamshul. Zuhair, Johan, Prasanna, Advait, is that clear? Because if you don't speak, I don't know how to proceed.
Ma'am, it's clear.
Yeah.
Okay. Fine. Now, right? See, A vector cross B vector is also, the cross product is a vector. When you were doing a dot product of two vectors was a scalar. Cross product of two vectors is a vector itself, right? So in that case, what I have to literally do is that, boys, let me, I'm striking this. In that case, I'll just use a highlighter. So I want to find, because C is a vector, so I have to find for I cap for this vector. Yes. Okay. I'm just forgetting the elements over here. I'm only taking these two elements, right? So when I'm writing this, it becomes minus left, it goes like this. Minus 3 into, is that minus 2? Minus 3 into minus 2 minus of 4 into 1 I cap. This is how the first one happens to be. Your aim is to find what is C vector, right, boys? I should not see the elements which are below I cap. I have to go for J cap and K cap. So right here I have minus 3 into minus 2 minus of 4 into 1. So what is that? This is for I cap. Next, I have to go for J cap. Jatin, others, is this clear, boys, what I am doing?
Yes, ma'am.
Stepwise I am doing, right? See, the cross product of two vectors, A vector and B vector, is also a vector. So that is your C vector. So that C vector should also have, should be expressed in I cap, J cap and K cap. So I have just found the I cap of your C vector. Next, I have to find the coefficient of J cap. Is the coefficient of I cap is clear? Next, I have to proceed for J cap. Is that clear for all of you?
Yes, ma'am.
If you have a doubt,
Yes, ma'am.
okay. So I'll close the bracket. Next, I have to go for this was 2. This was I cap and was this was minus 3, correct? This had a value of minus 2. Now what I need to do is that I have to forget all the values over here. Clear? Now 2 into it becomes 2. This way I have to multiply and I have to multiply, right? So when I go for J cap, it should be negative of, right? So 2 into minus 2. Can you see this arrow, boys? 2 into minus 2 minus of 4 into minus 3. 4 into minus 3 J cap. Are you clear? So whatever elements you have below J, you have to forget. So what is left? You will be left with 2, 4, minus 3 and minus 2. So minus, after you finish your I cap, there should be a negative sign. 2 into minus 2 minus of 4 into minus 3 J cap. Is this clear for all of you?
Why is there a minus after I cap?
No, it's always for J cap, we should have a minus
Oh.
sign.
Then it
For
will
k
also
cap it will
minus
be positive.
K
Yes.
cap. Okay.
Next,
Okay.
for k cap it's fine. Okay, now I'll have to go for finding the coefficient of k cap. So I'm just erasing it. Okay. Now I'll take the highlighter. So whatever is in k cap, I have to forget those elements. So whatever I'm highlighting, I'm just neglecting those numbers. Now I have this. So in that case, I have to go for 2 into 1. Okay. So when you are going for the coefficient of k cap, it will be plus 2 into 1. Because I'm starting always from left and then right. 2 into 1 minus of minus 3 into minus 3. Is that clear? K cap.
Field zone.
Where is it? Was just put this in your chat box. So try to do this tomorrow when we are solving this numerical. It should not take much time, boys. Please put this in the chat box. Practice this. Practice this. This chapter needs a practice from your side also, boys. Thank you.
Yes, we got need practice. Thank you.
Okay, thank you.
Thank you, ma'am.
So a sincere advice from my side is that, especially this chapter, whatever you learn, just spend at least 15 to 30 minutes, boys. Otherwise, it will become tough for you. The other chapters, fine. There is no, you can manage, but this chapter needs more time from teacher's point of view as well as from your point of view. Just keep doing it. Just, otherwise, what happens is that one full period will be taken for one single concept. Thank you, boys. You can leave. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.